Well, hello scrappers, Mike here, welcome back to my channel. Today is the day I finally rebuild my Foundry furnace. It's a mess. It's been a mess for a while. I've been threatening to rebuild it in a lot of different videos. Well, the other day I had a massive boil over in there, and that did it in. That was the final straw. It basically fell apart. So it's time to rebuild it. I've got pretty much everything I'm going to need right here. The main thing I'm going to need is some ceramic fiber blanket, and it goes by several names. This is Inns wool. There's also Kea wool, and there's other brand names too. But this stuff works really well. It handles the temperature inside the Foundry furnace really well and stands up for a long time. You're going to need a little basic PPE while you're working with it because the fibers on this stuff are annoying. It's kind of like working with fiberglass. You really don't want to breathe the fibers, so get yourself a face mask. Some gloves, not just to keep the fibers off your hands, but also because we're going to be working with baling wire, which can be a little sharp. We're going to need a knife, sharp knife for cutting this stuff. Pliers for working with the baling wire. We need something to use as a form for the inside of the furnace to give it its inside dimension. And I just got a piece of duct work here. I think this is 8-inch duct. And we're just going to wrap 2 layers of fiber around the duct, baling wire it into place. And, you know, that's a quick and dirty furnace right there. As an optional step, I've got some sodium silicate solution here, or water glass as it's also known as. And one thing you can do is you can sort of saturate the finished furnace with a 50-50 mix of this stuff and let it dry out, and this will make the fiber a lot stiffer and it'll last a lot longer. I will probably do that since I still have a fair amount of sodium silicate solution here. I'll mix up a 50-50 batch of it, put it in a spray bottle, and just spray the furnace down really well with it once I've got it made. As this stuff sets up, it combines with carbon dioxide out of the air, and it'll set up and it'll really rigidize this fiber in here, and the furnace will last a lot longer that way. So let me get started. I'll reposition the camera so you can see what I'm doing, and we'll get started working on this stuff. I'll put my PPE on too before I start pulling fiber out of there. Let me reposition the camera because it's starting to rain and the camera's out in the rain. Well, that was kind of unexpected because rain wasn't really in the forecast. So anyway, I've pulled some of the fiber out and I've got it spread across my work table here. And what I'm going to do is I'm going to cut it in half lengthwise because I want my furnace to basically be 1 foot tall. Okay, and this is 2 feet. So I'll be able to get 2 wraps out of this just to maximize the usage of the fiber here without wasting it. Okay. Now this form is about 13 inches tall, so it's a little taller than I want, but it's the right diameter. I want about 8 inches on the inside diameter. So let me cut this into 2 1-foot sections. Yeah. Rain wasn't really in the forecast, but I guess Mother Nature had her own ideas. Okay, so now we got 2 1-foot sections of this stuff. What I want to do is just wrap it around my form, like so. And then cut it where they're going to overlap. Like that. And I've got one wrap. So let me get my baling wire and I will tie this stuff on, and then we'll put another layer over the top of this. I like to do 2 layers. 1 layer actually may be enough for most work, but I like to do 2 layers. It just makes it that much more rigid and lasts longer. I mean, the last one, this was my first foundry furnace I ever built that just failed on me. And I built that probably 5 years ago. And originally I built it inside a 5-gallon metal bucket. Well, I've used that thing for so long that the metal bucket had totally rusted away. But because I had rigidized the wool inside with sodium silicate, after the bucket rotted away, everything was still nice and rigid, and it still worked just fine. So okay, so there's 1 layer. Let's put another layer on. And I just put 1 tie on this, which I didn't do a very good job of, but it should hold it together. So I just put 1 tie on this, but we'll tie the outer layer a little better. And I'm going to make sure that the seams do not overlap, so that there's no good place for the hot gases to escape. Are you seeing how easy this is? I'm going to have a foundry furnace here in a few minutes. It's just so easy. I was tempted to take my gloves off to make it easier to manipulate this baling wire, but I know I'll end up bloody. I tend to be kind of klutzy with sharp things, and the end of this wire is sharp. So I'm going to put a couple of wraps on this to hold it together. Maybe 3. Top, middle, and bottom, I'm thinking. I'm not going to wrap it too tight, though. I just want to hold it together. Straighten this stuff out a little better. This is going together really, really easy. I don't know why I put this off for so long. It's so darn easy. Guess I was just always in a hurry to do the next smelt or metal melt or whatever. And it's like, oh, it'll survive 1 more. It'll do 1 more. It'll handle another one. Until finally it wouldn't handle another one. But hey, like I said, about 5 years I got out of it, so that's a pretty good run. Pretty happy about that. Okay. So there we are. That's pretty much all there is to it. Wrapping could be a little more even, but not a big deal. Lay these down so they're not sticking out to snag me or anything else. Okay. Now you might be asking, where's the hole for the burner? Well, I haven't made that yet, and I think what I'm going to do is I'm going to wait on that for now. You could just, with a hole saw, go in here and make a hole really easy, okay? And I would probably do it right above this bottom wrap. put it in at an angle so that the flame swirls around your crucible in there and heats it from all sides. A hole saw will cut right through this stuff like it's butter. But it's better to do it, I think, after it's rigidized. Like I say, you don't have to rigidize this thing. This will work as it is just fine. You'll probably get a whole lot of smelts and metal melts out of it just as it is. But I'm going to rigidize it just so maybe it'll last another few years. And then once the fiber is good and rigid, it's really easy to go at it with a hole saw and make a nice clean hole through it. As it is right now, you know, you could even just with a knife just cut a hole to put the burner in. But I'm going to wait. I'm going to rigidize it. So let me mix up some sodium silicate and water, and we'll start hosing this thing down with that so that it can harden up and get good and rigid. Okay, let's mix up some sodium silicate solution. So I've got a spray bottle here. I've got about 10 fluid ounces of water in it. And I'm going to add about that much sodium silicate solution. You might want to wear gloves for this. Just want to make a 50-50 mixture, so I got to get this up to 20 fluid ounces. Close enough. Give it a bit of a mix. And before we start spraying the foam, I would recommend you put your dust mask back on. You don't want to breathe the little particulates, or you don't want to breathe the little droplets coming out of here. And eye protection would be a good idea as well. So let me put my PPE back on, and we will start soaking down the newly made Foundry furnace to rigidize the fiber. Okay, so I was going to do this out in the sun, and the sun just came back out, but I don't know, it might rain again, so I'm going to do it in here. There we go. I've got a little metal plate here to protect my workbench from my long-suffering workbench from the sodium silicate solution. I'm just going to saturate this fiber inside and out and along the top and bottom with a goodly amount of this sodium silicate solution. I'll spin it around and do the other side. I'll flip it over and do the bottom or the top. Haven't decided which end's going to be up yet. Doesn't really matter. And a couple of days sitting out in the sun will dry it out and harden up the sodium silicate and rigidize the fiber something wonderful. You'd be amazed at how much stiffer this fiber gets after this treatment, without really losing much, if any, of its insulating properties. Actually kind of pat together the flyaway bits while it's wet, and it will harden into the shape you mold it into. So we flip it over and give it the same treatment on this side. And you could give it a couple of treatments if you want. I think one will probably be enough, considering it's taken me all of about 10 or 15 minutes to build this thing. I think it took me longer to find where I had the ceramic fiber blanket stored because I bought it when I built my first Foundry furnace. Oops, it's in storage. That's pretty good. It's pretty well saturated. It's wet everywhere, top and bottom. And if the sun comes out and stays out, I'll move this out into the sun to help it dry out quicker. I could also put it in front of a fan. That would help. In fact, I think I'll do that until the weather clears up. So we got not only drying going on here, but there's a chemical reaction between the sodium silicate and the carbon dioxide in the air, and it's kind of like cement setting the reaction, and it will get a lot more rigid. All right. Okay. So now it's just a matter of waiting for it to harden up. So we'll be back when that happens, and I'll show you what the next steps are into turning it into a decent foundry furnace. So there it is in front of my big fan drying out. I'll probably leave it there the rest of the day. Like I say, if the weather improves, I'll take it out and leave it in the sun. This is not really the video I wanted to make today. I wanted to actually do something using my old foundry furnace, but decided there was just no hope for it. And, well, high past time to make a new one, so at least we'll have a nice shiny new one for the next series of videos. Okay, so we just gotta wait for this to dry. Okay, the rain clouds have moved on out, the sun's out. I've got this out in the sun, letting Mother Nature dry it out for me. I've also got it sitting up on the little pedestal it's gonna operate on. This area gets boggy when it rains a lot, and I don't want the foundry furnace to be waterlogged, so I've built it up a few inches with some concrete pavers. So it's going to sit up here, and for a floor inside there, what I'm going to do is I'll just put a couple inches of sand, like playground sand. You can actually see the remains of this floor from the last one there on the ground. That sand will protect the concrete pavers from the extreme heat that's going on inside the furnace. Otherwise, the concrete will crack and spall. Also, the sand will absorb any sort of spills or splashes or splatters. It's really easy to replace it rather than having some sort of rigid floor. And sand is really good insulator too, I have found. So, yeah, once this is dry, I will drill a hole for the burner. The burner's sitting on the ground over there. That's the burner from the last one. Oh, I'll put a link to a burner in the video description in case you need a burner. And so I'll drill a hole for the burner. I'll put in a sand floor, and we'll fire this thing up and melt something with it. Make sure it works good. We just got to wait for it to dry out and harden up. That may take a day or two. But Mother Nature's working on it. Sun's out. Okay, it's the next day, and this has hardened up and dried out very quickly out here in the sun. It's not exactly rock hard, but it is much stiffer than it was just as the raw fiber. It's really got some rigidity to it, which is exactly what I wanted. So now it's time to drill a hole in it for the burner. So I got a diamond hole saw in my drill. You could probably use a regular hole saw. I like the diamond saws because they don't tear the fiber out as bad, you know, as a tooth saw would. So I'll zoom in a little bit, and we'll drill a hole in this sucker and get it ready to go. I'm going to drill it at an angle like this so we get some swirl. Pull the first layer out. Pull the second layer out. Now we got a hole in the side. Insert the burner in here, like so, at an angle. I'll give you a look down the throat of the thing, and you can see how it's coming in. Kind of like that's what I was aiming for. So we got a little bit of an angle. The flame will come out and swirl around in there and surround the crucible. All right, the next step is I need to put a couple of inches of sand on the floor of this thing to make a base for it, so that number one, it doesn't move around, and number two, that's going to insulate it so that the concrete doesn't get hot down there and crack and spall. So let me go get some sands. Okay, in goes the sand. This is just ordinary silica sand. Just like playground sand or sand you would use for mixing up mortar or cement. Just going to put a couple inch layer on the bottom. Spread it out a little bit. Make it smooth. Alright, need one more thing. We need a plinth for the crucible to sit on. I don't like it to sit on directly on the sand. So for that, I've just got a scrap piece of fire brick here. Put that down there, and we're good to go. I'll give you another look down inside the furnace. There we are. That's what we're aiming for. I got my furnace back. And that was quick and easy. Man, I should have done this months ago. Okay, now we just need something to melt. Let me look around, see what I can come up with. So what are we going to melt to test out the new Foundry furnace? Well, I have here some cement copper from my waste bucket. I've talked in the past about how I handle my waste from gold recovery. You know, I've got a stock pot that the waste fluids from recovering gold go into. I keep copper in it to cement out any leftover precious metals in that fluid. And then the liquid from the stock pot goes into my waste bucket, which I keep full of iron and steel. And all the copper from the stock pot cements out on the iron and steel as copper powder. So that's basically what this is. This is basically copper powder. It's crude copper. It's got a lot of contaminants in it. There's going to be like rust, paint chips, carbon from the steel, which dissolves over time as the copper cements out. Organic material, you name it. You know, there's all kinds of stuff in here. So this is fairly crude copper. But I'm going to try and melt some of it down and see what kind of a bar we can make out of it. I'll see if I can clean it up a little bit. So let me get some of this, and we'll put it in a crucible. Some of this powdery stuff in here to fill the voids between the chunks. And I have a lot of this cement copper. In the past, what I've done with it is I have put these crude bars I make by melting this stuff down through my electrolysis cell and get pure copper, which I don't really have a need for pure copper, but the sludge in the bottom of the cell contains some precious metals that made it through my stock pot and through into the waste bucket. Since then, I have been much more fastidious about dealing with the stock pot, so I doubt there's much in the way of precious metals here. But who knows? Maybe I'll run another set of bars through the electrolytic cell and we'll see. Anyway, I'm going to top this with some borax, anhydrous borax. The borax will help the copper melt down nice. It'll also form a slag, which will float on top of the molten copper, and it'll pull away a lot of the impurities in the copper into the slag. And then we can just chip the slag off of the bar, and hopefully we'll get fairly pure copper out of it. So let me get this in the brand new Foundry furnace, and we'll get it melting down and see how it goes. Melting copper, you know, copper has a pretty high melting point, so this will be a good test of the new furnace to see how well it works. Okay, so let's get this stuff into the furnace. Now, people are always telling me, put a piece of cardboard or some folded paper on top of your plinth in there, and your crucible won't stick. Yes, I've watched Big Stack Castings videos too, and that works sometimes. If you have a boil over, all bets are off. If you've had previous boil overs with your crucible and there's slag on it that's going to melt, well, it may not work anyway. So we'll give it a shot though, since everybody's always hollering at me to do it. All right, let me get this thing lit, and we'll get this melting. Okay, first light of the new furnace. Down in here. And there we go. We are off and running. I still have these lids from the previous furnace. I'll put them on top here. They just help sort of constrict the outlet so that it keeps more heat in. This constricts it even more. So we'll just give that a chance to heat up, and we'll see what happens. I'll get my crucible tongs and my mold ready, and hopefully we'll have a nice pour here in a little while. So it's been a little while. Everything's melting down nice. The borax on top's all melted. Get a little bit of green flame coming out. Get a little bit of white smoke out too, because some of the steel I put in there to cement this stuff out on was galvanized, so there's probably some zinc in there. I imagine that white smoke, some of it's zinc. Of course, we're also cooking off the other stuff, the organics, paint chips, whatever else is in there. But I'm going to stand upwind of that white smoke. And I might need to add more borax. We'll see. I'm going to let this get a little hotter, and then I'll start stirring it with a steel rod and see how it looks. If it looks like it doesn't have a good slag layer on top, I'll add some more borax to it. Okay, but for now, I'm just going to keep it heating up. Furnace is working good. Look at that interior color. Bright orange everywhere. It is hot in there. I don't even have the burner turned up full. It's working good. Okay, I'm going to put a little bit more borax in. So it looks like what was in there has kind of soaked down into the powder. I want there to be a good slag layer on top. Once the powder melts, it probably will flow up on top, but I'm just going to add a little bit more. The volume of material in the crucible has settled way down. Not only has the borax soaked down in, but I think that the powder is starting to consolidate a little bit and lose volume. I could probably actually put some more copper in there, but I think I'll leave it alone, and we'll just see how much copper we get out of this melt. Okay, let me see if I can give you a look at what's going on in here. It looks like the copper has melted. The volume of material in the crucible has gone way, way down. So let me get my steel rod, let me give it a stir, and see how it's looking. Oh yeah. The copper has melted. Good. And it looks like we've got slag floating on top. Give it a good stir here. I still see some lumps of something. I don't know what it is. Yeah, I'll let that go for a few more minutes. Oh, anybody need to be branded? Step forward. Yeah, we'll just let that go for a few more minutes. Let me find my mold and get it preheating, and then we'll have ourselves a pour. There we are. I'm preheating my loaf mold there. Cast iron loaf mold. I'm thinking what I might try to do is scrape some of the slag off of the surface of the molten metal in there before pouring it and see if we get a cleaner pour that way. Because a lot of times when I just pour it with all that slag on top, I wind up with a lot of voids in the copper bars from slag that's been incorporated. So I might try that, as long as I can do it without setting myself on fire. Might try that. Anyway, we'll get this mold preheated and pull the crucible out and take a look and see if we can scrape some of the slag off. Probably put it back in to heat it up again and then pull it out to pour. Okay, the mold is good and hot. I'm going to take it off in a second. I'm preheating my scraper bar here. I can scrape some of the slag off the top of the liquid before we pour it. I like to preheat this stuff, otherwise the slag just instantly hardens out on it. Slag and metal. So, that's good and hot. Let me get this off of here. Set this down here for later. Turn the heat off. There we go. Get the crucible out of there, and we'll scrape some of the slag off. Yeah, see, my plinth stuck anyway, didn't it? So, oops. Ooh, the radiant heat is murder. I will collect any copper that comes out with this slag and reprocess it in a future pour. Put this back in and give it a quick reheat before we pour the copper. Alrighty, time to pour. Yeah, I saw some copper metal there under the slag. There's still a fair amount of slag there. Hopefully I could just knock it off with a hammer. And hopefully not too much of it got incorporated into the bar. We'll see. We'll give that a little while to harden up and we'll turn it out and see what it looks like. Okay, let's see what we've created here. If it'll come out of the mold. Well, my concrete's breaking, but there we go. Yeah, it's got some voids in it, like usual. Got a layer of slag on top. We'll let that cool down and have a closer look at it. See what we got. Alright, so here we go. Let's have a look at this. I think we got lucky. Differential contraction. The slag layer broke loose from the copper layer. Isn't that nice? And here's our crude copper bar. That's a hefty chunk of copper. I could chip some more of the slag off of it. Probably need to do that. But maybe we'll just weigh it up as is and get some idea just how much copper we've got here. Okay? Let me get my scale. Let's see what we've got here. It's cooled down enough to touch. Yeah, it was temperature of boiling water there. 1 pound, 3.6 ounces of copper. Not bad considering it came from a waste product. Okay? And I've got plenty more. I've got a whole lot more. In fact, I probably have 10 times this much cement copper sitting back there between my old, between my old waste bucket and my current waste bucket, I've probably got at least 10 times this much copper. Cool. I think the new furnace is working pretty good. It's getting up to the temperature of melting copper without any trouble. We clean up this ingot a little bit and see how it'll look cleaned up. So here's what we got after chipping most of the slag off and giving it a good wire brushing. Not a very pretty ingot, but definitely mostly copper. I'm sure it's got a little bit of tin, a little bit of zinc in it probably. I guess technically it's a bronze, but it looks like copper. So what I'm thinking about doing is melting down a bunch more of this cement copper, cleaning up the bars like I cleaned up this one, and then remelting them to get a lot purer, cleaner copper. So I might do that in the future. But now that I've got a working foundry furnace again, I need to get back to the project I actually wanted to do, but couldn't do because the furnace was broken. So I think the next video you'll see me doing something else, but maybe we'll be melting some more copper in the future. Let me know if that interests you, if you'd like to see some more copper melted in the future, and I will film it if there's an audience for it. Well, I think the new furnace is working great, and it didn't take me that long to build. So you saw the whole process. It went pretty quick and easy. So I'm happy. I hope you're happy. If so, give the video a like, give it a thumbs up, and subscribe to see my future videos where we'll be melting and smelting and doing all kinds of stuff in this furnace in the future. And subscribe to see those future videos. And check out my second channel, Electric Geek 64. There's good stuff going on there if you're all interested in electronics or retro computing. And I will see you in the next video. Thanks a lot for watching this one. Bye. So while everything was good and hot, I decided to do another one. You know, I had everything out, so I might as well. Second bar turned out even better looking. Well, not that side, but even better looking than the first one, and it's heavier too. See what we got here. 1 pound, 6.4 ounces. Yeah, so altogether today, 2 pounds, 9.8 ounces of, pure-ish copper. So not a bad morning's work. So like I said, let me know if you want to see more copper melting videos. I've got plenty more cement copper to melt down. And what I want to do is once I accumulate a fair number of these bars from melting down the cement copper, I want to melt down these cleaned up bars and see if I can pour even cleaner, nicer looking bars by remelting these and pouring them. So let me know if you want to see that, and that might happen in the future. Anyway, there's your post-credit content. Thanks for watching. See you in the next video. Bye.